So we'll start. So in the last video lecture, I had taken the first example on the right circular cone. Now we'll start with the second example. Find the equation of right circular cone whose vertex is 1, minus 1, 2 and axis is the line x minus 1 upon 2 equal to y plus 1 upon 1 is equal to z minus 2 upon minus 2, and the semi-vertical angle is 45 degrees. So we'll start with the solution. Let P of xyz be any point on generator given vertex A 1, minus 1, 2. drs of AP are x minus 1, y plus 1, z minus 2. drs of axis are 2, 1, the drs of axis are 2, 1, minus 2 and theta is equal to 45 degrees. Now here you are having this is x minus 1, y plus 1 and z minus 2 are the direction ratios of AP, and direction ratios of axis are 2, 1, minus 2 and theta is equal to 45 degrees. Then using the formula for cos theta, what is that? Cos of 45 is equal to 2 into x minus 1 plus 1 into y plus 1 minus 2 into z minus 2, then divided by square root of square of this 2 square, square of this 1 square and square of this minus 2 square, then square root of square of x minus 1 square plus y plus 1 square plus z minus 2 square. These are the two square root values. Then cos of 45 degrees is equal to 1 upon root 2, and then this is 2x plus y from this minus 2z from this, then this is minus 2, this is plus 1 and this is plus 4, that is equal to plus 3. Then this is 3, that becomes equal to 4 plus 1 is equal to 9, and square root of 9 is equal to 3. Then this square root will remain as it is, so that we are squaring on both the sides and then we are simplifying. This becomes a 3 square into this square of this value, square root will get cancelled, becomes is equal to 3 square is 9, and then square of this root 2 goes on the right hand side and it becomes 9 times x minus 1 square plus y plus 1 square plus z minus 2 square is equal to 2 times 2x plus y minus 2z plus 3 square. So either you can put this value as it is, or you can again simplify just by x minus 1 square, y plus 1 square, and this is a plus b plus c plus d square is equal to a square plus b square plus c square plus d square plus twice ab plus twice bc plus twice cd plus twice this cd, and then this is a twice of the last value. Okay, so you can square and then put the result, or you can put this itself, 9 times of this is equal to 2 times of this. So that becomes the solution for the second problem. Then we'll go to the third problem. Find the equation of a right circular cone generated when the straight line 2y plus 3z is equal to 6, x is equal to 0 revolves about z axis. Now here again we'll go for the solution of this. The vertex is point of intersection of the line 2y plus 3z is equal to 6. Okay, so this becomes the vertex at the point 0, 0, 2, and this becomes any point P of xyz on the right circular cone which is along z axis, because x is equal to 0 and the z axis x is equal to 0 and y is equal to 0. So therefore, when x is 0, y is 0 and z is equal to 2. So therefore, when you get this y is equal to 0, 3z is equal to 6, implying z is equal to 2. So therefore, x is 0, y is 0 and z is equal to 2. So this becomes vertex of the right circular cone. And the generator of the cone is x upon 0 plus y upon 3 plus z r is equal to x upon 0 equal to y upon 3 equal to z minus 2 upon minus 2. Then when you go on simplifying, here if you see that direction ratios of the generator are the denominators, that is 0, 3 and minus 2, and the axis is the z axis. The DRs of that z-axis are 0, 0, 1. The semi-vertical angle alpha is therefore given by, again you'll have to go back to the formula, cos alpha is equal to, that is equal to x is equal to 0, 0 into 0, then y is equal to 3, but you are having y is also equal to 0 at that point, and this is minus 2 and z is equal to 1. So therefore you get square root of 0 plus 9 plus 4, that is equal to square root of 13, and this is square root of 1 is equal to minus of 2 upon 3, that is equal to 2 upon 13. Then this becomes cos alpha. So let Pxyz be any point on the cone so that the direction ratios of AP are x, y, z minus 2. Since AP makes an angle alpha with AZ, we have cos alpha is equal to x into 0 plus y into 0 plus z minus 2 into 1 divided by square of this plus square of this plus square of z minus 2 square. Then squaring on both the sides, you get, that is the square root will get cancelled, and then you get this value is equal to x square plus y square plus z minus 2 bracket square, and this is z minus 2 bracket square in the numerator, and then this becomes cos square alpha when you are squaring on both the sides. Then this cos square alpha, already we have seen this is equal to cos alpha. Cos alpha is minus 2 upon 13. So cos square alpha becomes minus 2 square is 4, square root of 13 will get cancelled, becomes is equal to 13. So therefore you have this value is equal to 4 upon 13. When you go on simplifying, again this becomes 13z minus 2 bracket square, this 13 will go on this side and 4 will go on this side. So when you go on simplifying, this becomes 13z minus 2 square minus, you can take this on this side, that is minus 4 times z minus 2 bracket square is equal to 4x square plus 4y square. 4 times of this is already taken on this side. Then you get 9 times z minus 2 bracket square is equal to, that is equal to 13 minus 4 is equal to 9. 9 z minus 2 bracket square is equal to 4x square plus 4y square. So again when you square this value, this is z square minus 4z plus 4, 9 times of this. So therefore this value is equal to 4x square plus 4y square. So again go on simplifying, this becomes a 9z square, and then this becomes a minus 36z, and this becomes plus 36, then is equal to 4x square plus 4y square. So take these values on this side, you get this is 4x square becomes equal to 4x square plus 4y square. This 9z square will go on the left hand side, becomes 9z square. This becomes a minus, minus becomes plus, plus 36z, and then this minus 36 is equal to 0. So this becomes the problem on the right circular cone. Then we'll go to the cylinder and then we'll define the right circular cylinder, and then we'll go for some of the problems on finding the problems on the right circular cylinder. Cylinder definition. A cylinder is a surface generated cylinder. A cylinder is a surface generated by a straight line which is parallel to a fixed line and satisfies one more condition. Example, it may intersect a given curve called the guiding curve. The straight line in any position is called the generator and the fixed line is called the axis of the cylinder. So we'll see the problems on this type of a cylinder, which is not a right circular cylinder. Actually, we'll be having the problems on the right circular cylinder and the definition of a right circular cylinder. First, we'll see this type of a general cylinder. So we'll take one of the examples and then we can understand the next part. Find the equation of a cylinder whose generating lines have the direction cosines L, M, N and which pass through the circumference of the fixed circle x square plus z square is equal to a square in the ZOX plane. So if you see this becomes, let P of x1, y1, z1 be any point of the cylinder, that is P of x1, y1, z1, so that the equation of the generator through P is given by x minus x1 upon L is equal to y minus y1 upon M is equal to z minus z1 upon N. So this is your equation number 1. Then given guiding circle is x square plus z square is equal to a square and y is equal to 0. So therefore the generator 1 cuts the plane y is equal to 0. So when y is equal to 0, then we get that x minus x1 upon L, that means this value, x minus x1 upon L is equal to this value, y is equal to 0. Therefore, I'll get minus y1 upon M is equal to, on the right hand side, z minus z1 upon N. So when you go on simplifying, you get the value of x. X is equal to L minus, that is equal to Ly1 upon M, and Z is equal to Z1 minus Ny1 upon M. But these values of x and z, so this is the value of x and this is the value of z, satisfy the equation of a circle, that is x square plus z square is equal to a square. That means substitute this value of x in this and the value of z in this, so that this, when you go on simplifying, you get this becomes m and this m will be common in both, becomes m square, goes on the right hand side and it becomes m square a square. So therefore I get mx1 minus ly1 square plus mz1 minus ny1 square is equal to m square a square. Hence locus of x1 y1 z1 is mx. So this is general value. So replace that x1 y1 z1 by x y z. You get the locus of the point becomes mx plus ly square plus mz minus ny square is equal to a square m square, which is the required equation of the cylinder. Now this is a general cylinder, not a right circular cylinder. We are mainly having the problems on right circular cylinder. Okay, so we'll go to the definition of a right circular cylinder and some examples on a right circular cylinder. A right circular cylinder is a surface generated by a straight line parallel to a fixed line and is at a constant distance from it. The fixed line is called the axis, the constant distance is called the radius, and radius of the cylinder, the section of a right circular cylinder by any plane perpendicular to the axis is a circle. So we want to find the equation of a right circular cylinder. Now how to find it? To find the equation of a right circular cylinder whose radius is r and axis is the line, x minus alpha upon L is equal to y minus beta upon M is equal to z minus gamma upon N. Okay, so this becomes the axis and you are having the radius of this right circular cylinder is R. Okay, so that means this becomes a right circular cylinder. Then, so this becomes a generator. So we take a point P, X, Y, Z on the generator. From that point P, we draw a perpendicular on the axis. Then this axis, this PM becomes the constant distance. And this constant distance is the radius of this right circular cylinder. Then we take any point on the axis. So we'll start like this. Let A be the point alpha, beta, gamma. So this is a point that is on the axis of the right circular cylinder, and AB is the axis whose equations are, this is AB whose equations are x minus alpha upon L is equal to y minus beta upon M is equal to z minus gamma upon N. Now this is already given. Okay, the axis of the line is given by x minus alpha upon L equal to y minus beta upon M equal to z minus gamma upon N. So this is already given and therefore we take that as the equation of the axis. Then we find the direction ratios of the line are the denominators. So this is L, M, N. They are the direction ratios of the line, and the DCs of the line are, that means these are the direction ratios. You want to find the direction cosines. Then how to find the direction cosines? Then that values are nothing but this is L upon square root of L square plus M square plus N square, M upon square root of L square plus M square plus N square, and N upon square root of L square plus M square plus N square. So when the DRs are given, then DCs you can find just by taking the corresponding components of L upon root of L square M square N square, M upon root of L square M square N square, and N upon root of L square M square N square. Then start with this. Let P, X, Y, Z be any point on the cylinder and PM perpendicular to AB. That in the figure already I have explained. This is any point on the cylinder and PM is perpendicular to AB. Then PM is equal to radius is equal to R. Okay. So again, I'll go to that figure, becomes clear to get the idea. So this becomes a PM. So this PM is equal to R. Okay. And then you are having, see for example, this becomes a right angle triangle. Okay. So therefore, you'll be having by that Pythagoras theorem, AM square plus PM square must be equal to AP square. Okay. So we'll be applying that formula. Then when you apply that formula, you get PA is equal to square root of x minus a bracket square, y minus b bracket square, z minus gamma bracket square, x minus alpha, y minus beta, and z minus gamma square root of and the square of this value. And what is AM? AM is the projection of AP on the line AB. So therefore, the equation of AM is given by x minus alpha into L divided by square root of L square plus M square plus N square. So this becomes the direction cosine of the axis and this becomes the direction cosine of the point. So therefore, the multiplication of this plus y minus beta m upon root of L square plus m square plus n squared, z minus gamma into n upon square root of L square plus m square. Okay, so these are the values of PA, AM and AM. So therefore, that from the triangle APM, what you are having? AP square is equal to AM square plus PM square. Okay, so this already I have shown you in the figure that AP square, this is hypotenuse square, must be equal to AM square plus PM square. So therefore, you get that value AP square is equal to AM square plus PM square. Then AP is known to you. That's equal to x minus alpha square plus y minus beta square plus z minus gamma square. Square root will get cancelled because of you are squaring this value. Okay, so this is AP. Squaring of this value, this will square root will get cancelled. This will remain. That is x minus alpha square plus y minus beta square plus z minus gamma square, and am square is the radius, that is equal to r square, and pm square, already we have found the value of pm is equal to l into x minus alpha m into y minus beta plus n into z minus gamma square of this value divided by square root of that will get cancelled, becomes is equal to L square plus m square plus n square. That was common for the entire value. Then this equation is the required equation of a right circular cylinder having the radius is equal to r and axis is the line x minus alpha upon L equal to y minus beta upon m equal to z minus gamma upon n. That means you will have to remember this equation of the right circular cylinder. So becomes x minus alpha square plus y minus beta square plus z minus gamma squared is equal to r squared into, and then you are having plus this value. This is equation number 1. Now we want to find the particular values of a right circular cylinder depending on the equation of a right circular cylinder whose axis is x upon L, y upon m and z upon n is obtained by putting alpha is equal to beta equal to gamma is equal to 0. So in the last part, this equation was x minus alpha upon L equal to y minus beta upon m equal to z minus gamma upon n was the axis. Now that axis is now given in the form of x upon L equal to y upon m equal to z upon n. Okay, then how to find the equation of this? Just put alpha equal to beta equal to gamma equal to 0 in this equation number 1. So when you put that value, then x minus alpha square, this alpha is equal to 0 becomes x square, this is y square and this is z square. Then this is 0 becomes lx plus my plus nz, and then bracket square divided by L square plus m square plus n square. Then this r square also will remain. Therefore, you get on the left hand side x square plus y square plus z square is equal to r square, that is the radius. Then lx plus my plus nz bracket squared divided by L square plus m square plus n squared is what is the equation of a right circular cylinder whose axis is x upon L equal to y upon m equal to z upon n. And now we want to find the equation of a right circular cylinder whose axis is the z axis. Okay, is obtained by putting L equal to m equal to 0 and n is equal to 1 in equation number 2. That means from this equation, I want to find the equation of a right circular cylinder whose axis is the z axis is obtained by substituting L equal to m equal to 0 and n is equal to 1. So that means for z axis, this direction ratios will automatically become, that is equal to L equal to m equal to 0 and n is equal to 1. So substitute this in equation number 2. So when you put this value, this becomes x square plus y square plus z square. This will remain same as far as the left hand side is concerned. R square also remains the same. Then you are putting L equal to M equal to 0. That means this part become equal to 0. Then N is equal to 1. Then I'll be having Z square. Okay. Then this is 0, this is 0, this is 1 square. Becomes 1 itself. So therefore, you will be having x square plus y square plus z square is equal to r square plus z square. Implying thereby this z square and z square will get cancelled. Then x square plus y square is equal to r square. Now if you remember, this x square plus y square is equal to r square becomes an equation of a circle. Okay, so therefore the equation of a right circular cylinder whose axis is z axis is x square plus y square is equal to r square becomes a circle. Okay, similarly you can find the equation of a right circular cylinder whose axis is along x and y are y square plus z square is equal to r square. This also becomes an equation of a circle having the radius r, and this is axis is along x axis, and this x square plus z square is equal to r square is a equation of a right circular cylinder, and x square plus z square is equal to r square is along y axis. So here along what axis, that part is absent. This is, so therefore, so we'll go to the next examples on the right circular cylinder. Then you can understand how to solve the problems on the right circular cylinder. Example 1. Find the equation of a right circular cylinder of radius 2, and equation of the axis is x minus 1 upon 2 is equal to y minus 2 upon minus 3 equal to z minus 3 upon 6. Okay, so here the radius is given to you, equation of the axis is given to you. Just you have to make use of that formula, and then you can just go on finding the solution of this. So we'll start with the solution. Let p x y z, so this point p x y z be any point on the cylinder. So this is the cylinder, p x y z is any point on it, and a 1 2 3, this is a 1 2 3 be one point on the axis. So one point on the axis is a 1 2 3. Then m be the perpendicular from p on the axis. So this is m. M is what? M is a perpendicular from the point p on the axis. Then distance ap. Now this is a distance ap, that is square root of x minus 1 bracket square plus y minus 2 bracket square z minus 3 bracket square by using the distance formula. So by using distance formula, this distance ap is given by this value. Then distance pm. So the distance pm is given by, this is 2, this is already given, that's the radius of the right circular cylinder, that is given by 2. So this is equal to 2. And the distance am, now you want to find this distance am. Okay, so to find the distance am, we get am is equal to projection of ap on axis ab. So again we'll go to the drs of axis. Drs of axis are 2 minus 3 6. We can find the dc's of the axis. Dc's of the ab are 2 by 7, that is equal to 2 square root of 2 square minus 3 square plus 6 square, that becomes equal to 49, and square root of 49 is equal to 7. So therefore dc's become 2 upon 7 minus 3 upon 7 and 6 upon 7. So therefore am is equal to, what is that? The product of these and x minus 1, the product of minus 3 upon 7 y minus 2 plus 6 upon 7 z minus 3. So therefore am is equal to, when you simplify, this becomes a 2x minus 3y plus 6z, then minus 14 upon 7. So this becomes the value of am. Then go to that right angle triangle apm. ap square is equal to am square plus mp square. Now substitute these values. ap square, that is equal to this value, and this is am square, and this is mp square is the radius, that is equal to 4. Then go on simplifying. You get, simplifying, we get 45x square plus 40y square plus 13z square plus 12xy plus 36yz minus 24xz minus 42x minus 280y minus 126z minus 294 is equal to 0. So I told you. So this is a plus b plus c plus d square. Okay, you'll have to apply this formula. So this is straightforward. X minus a square, y minus 2 bracket square, and all this. Okay, you can simplify and get. Then we'll see the last problem on this topic that completes unit 5. That is example 2. Obtain the equation of a right circular cylinder of radius 5 and the axis is x minus 2 upon 3 equal to y minus 3 upon 1 equal to z plus 1 upon 1. Again, one point is given as a, that is 2, 3 and minus 1. DRs of axis are 3, 1, 1. Radius is equal to 5. Okay. Let again, as in the last case, let P, X, Y, Z be any point on the generator of the cylinder, and A, 2, 3, minus 1 be one point on the axis, M be the foot of the perpendicular from P on the axis. Then AP is equal to, again as in the last case, is X minus 2 bracket square, Y minus 3 bracket square plus Z plus 1 bracket squared. Then direction ratios of the axis are 3, 1, 1. Direction ratios of the cosines of this, that means the DCs, are, again go for the square root of this. 3, 1, 1. 3 square is 9. 1, 1 become 9 plus 1 is 10. 10 plus 1 is 11. That is 3 upon root 11. 3 upon 1 upon root 11. 1 upon root 11. And PM is the radius is equal to 5. Then AM is the projection of AP on the axis is given by 3x plus y plus z minus 8 upon root 11. Then from the, as in the last case, triangle APM, AP square is equal to AM square plus PM square. Again, the same formula, apply this and go on simplifying. Now here I have simplified on the right hand side, which is equal to, so this is left hand side, this 11 goes on this side, this becomes simple. Then I have solved this as 3x square is 9x square, y square is y square, z square is z square, minus 8 square is 64. Product 2 times the product of this is 6xy. 2 times the product of this, that is equal to 6xz, and this is xy xz, and this is 24 into 2 is 48x, and then 2 times the product of this is equal to 2 times yz, then 2 times the product of this, that is equal to minus 8 into 2 is equal to minus 16y. Then you are having 2 times of, that is equal to 2 times of this value, that is equal to 16z, and this is equal to 8 square, and then you are having this 11 goes on this side, becomes 25 into this value becomes equal to 275. Then when we go on simplifying, you get 2x square plus 10y square plus 10z square. Here you are having 11 x square, and this is minus 9x square becomes equal to 2x square. Similarly, all other values. So 2x square plus 10y square plus 10z square minus 6xy minus 6xz minus 2yz plus 4x minus 50y plus 38z minus 222 is equal to 0. So this becomes the end of unit number 5. So in the next week, I'll go for introducing unit number 6, which is contains the double and triple integrals and the applications of that double and triple integrals or multiple integrals and their applications. Up till that, thank you.